Example 3 is a little bit more of a thinky problem. So example 3 talks about water running into a conical tank. That's a cone, and it's annoying as all get out, but all of the conical tank questions on the AP exam are always these tanks that are point down. So I don't understand it either, but we get this tank point down, and we've got water rushing into the cone. So we've got kind of a spout that's sending water in. And it says it's running in at a rate of 9 cubic feet per minute. So that's the volume. We're talking about the water level in here. So they've given us the change in volume with respect to time is 9 cubic feet per minute. The tank stands point down, told you so, and has a height of 10 feet. So height is 10. And I'm going to just draw that onto my picture as well, that the height of this tank is 10. The base radius, that's up here, is 5. And they want to know how fast is the water level rising when the water is 6 feet deep. So here we've got some random R value, and then we'll call this value the water level. That's the height. So they're wanting to know how fast is the water level rising? What is the change in this level? So we want to know what is dH dt. So notice we've got R, H, and V, and we need to come up with an equation that relates all of those. So the volume of a cone equation, which most of you probably won't remember, but that's all right, 1/3 pi r squared h. Now, this r value is not fixed. This h value is not fixed. The problem is I don't have dr dt. So if I just straight up did the derivative here, I would end up with a dr dt and a dh dt. So this question is based totally on the height. So what we have to do is come up with some way to eliminate r as part of this equation. I want to replace r with something. The nice thing is they've provided this nice proportional relationship here. They said the relationship of radius to height was 5 to 10. Which means if I solve this proportion, if I solve for r, I get that r equals 5/10 or 1/2 h. So I can use this information in this equation, and now my equation will be completely in terms of h. So my new equation is 1/3 pi 1/2 h quantity squared times h. Now 1/2 h quantity squared is 1/4 h squared. And so now if we combine all of these things, 1/3 times 1/4 is 1/12 times pi 12ths, and then h squared times h is h cubed. There's my simplified volume formula. Now we want to use this formula to find rates. So the change in volume with respect to time, derivative of v is dv dt. Now pi 12ths is just a number, not a scary number. We just do the power rule. So 3 times pi 12ths is 3 pi 12ths, which is the same thing as pi over 4. H squared dH dt. Now I've got all this information over here that I can plug in. We know that dV dt was 9 pi 4ths. We know H at the time that they're looking at when the water was 6 feet deep. So I also need to make that note up here as well, that we're talking about the snapshot when H is 6. So this was 6 squared times dH dt. And that's what we're trying to find. So 6 squared is 36. 36 divided by 4 is 9. So I get 9 equals 9 pi dH dt. So when I divide by 9 pi, we get that dH dt equals 1 over pi, which I believe is about 0.32. I believe, double check on your calculator, 0.32 feet per minute.